All right. Got a couple of minutes here before we get started. Um, Apologize for my last video. I mentioned it previously, but I started right at 12 and I started my OBS broadcast and I forgot to hit the start stream button on YouTube. And so I didn't verify my stream and I ended up doing an entire video to the ether. So I posted my solution. But while we got a couple of minutes here, I just want to review kind of my framework that I have set up. So I'm using Cobra, which is a Go library to structure my projects into logical 2022, 2023, 2024 directories. And each of those have a root command of the respective year. And then inside of those, each have the root command of the respective day. And then each day is its own folder with its own part 1, part 2 text, and its own test and test 2. They do change, but not usually. At least gives me that flexibility. And then a test to run with some set of inputs and some expected output. In this case, day 2 is a copy of day 1. I haven't completed day 2 yet, but it kind of gets me set up so I can get started. And so this gives me the ability of not only testing input here, so we can write tests, but also we have the ability to run any day and get back a result. So if I want to run the previous days, I can output the results for myself here. And so the idea is that we can run this and have a catalog of what our values are. I did do some research and I did create this grid component library previously. We'll probably use this again. I also created a grid F for floats. That way we can work with floats. We can even change precision later if we want. And that's fine. What I did realize is that I could not use this library because the rotate function is dependent on a square grid, meaning the length and width are equivalent. And so I would need to rework this to rotate a non-square grid, which I can do at a later time. The idea here was that we could use these grid functions to quickly kind of parse data. So we'll try to utilize those moving forward. The concept is pretty straightforward. You have some sort of input with some sort of separator. And so every line is a row, and then the separator delineates the column. And those get written into some sort of grid. And then you can use that information turn into a grid of floats or grid of ints. And then you can rotate the grid if that's something we want to do. That's a possibility. I'll have to look into this a little bit further, but the idea would be in day 1 scenario, ideally instead of having this parse columns, we could just do a grid rotate as a grid F, and then we would just be able to use grid position 0 and grid position 1 here, and we wouldn't have to have this custom parse column function. So that's kind of the idea behind this framework that I have. It's not really meant to make my life to do these fast, I guess you could say. The goal here is to just work through them and kind of complete them. I'm doing advent of code for my own flexing of my own ability, just kind of as a brain exercise would probably be a better way to put it. Keep my skills sharp and thinking in the right train of thought. So day 2 has some boilerplate from day 1, and we'll switch that out here shortly. In fact, I'll just maybe I'll just leave it here and maybe we'll see what we can do with it. So we've got a couple minutes here, 6 minutes and 46 seconds. So we'll see what we can put together. So you can see I'm kind of getting over a cold here. Let me take a look real quick and just kind of look at past calendars. Where do I look at that? Yeah, you can kind of see the past 2021, 2022, and 2023. Almost completed 2023. Yeah, I think I'm just gonna get rid of this. Let's see what happens. Actually, I'll leave that in there. All right, I'm excited. Excited to knock this out. See what we get today. Oh, some fun stuff. I kind of threw this into ChatGPT and I said, hey, can you summarize day 1? It said, Admin Code Day 1 summary. The chief historian of the North Pole is missing, and the Elvish senior historians need help reconciling 2 lists of historical significance location IDs to continue their search. The day consists of solving 2 puzzles, total distance between lists, and similarity score. Based on those 2 things, the historians now have more clarity on reconciling their lists and can proceed with their search for their chief historian to save Christmas. It's exciting. We get to save Christmas once again. Or at least go as far as we possibly can. Let's see what day 2 brings. Yeah, so the problem I have right now. This does a rotate in place, which is fine. All right. Two minutes and counting. Wonder what the puzzle's going to be today. We look at previous puzzles. We look at like year 2023. Let's see what we had here. Get score function. Oh, this was based on colors. And then a switch. Interesting. Okay. We'll see what 2024 brings. Right. So 1 minute left and counting. I think what we'll do here is, because everything's kind of based off this grid library that I'm kind of creating, I need to beef this up, that if we don't have a similarly sized grid that we can rotate, then I think we can use this pretty much for all the inputs. So, all right, 41 seconds. $30 seconds. $20 seconds. Here we go. 3, 2, 1. Here we go. Apparently clicking on it 6 times doesn't make it load any faster, so guess we're not the only ones trying to get to it right now. Okay. Still nothing. Oof. Advent code. Looks like they're having a bit of a overload of usage. We'll just contribute to the problem. Reload the page again, and again, and again. There we go. Day 2, red-nosed reports. Fortunately, the first location the historians want to search is in a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion fission plant appears to contain no signs of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. The unusual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. For example, this example data contains 6 reports, each containing 5 levels. The engineers are trying to figure out which reports are safe. The res-nosed reactor safety system can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing. Any two adjacent levels differ by at least one and at most three. The levels are either all increasing or all decreasing. Any two adjacent levels differ by at least one and at most three. Okay. So you can't have too steep of an incline or decline, and we have to be going generally in the same direction. So 7, 6, 4, 2, 1 is safe because we're decreasing. 7 to 6 is 1, 6 to 4 is 2, 4 to 2 is 2, 2 to 1 is 1. Okay. Unsafe because 2, 7 is increase of 5. Okay. Unsafe because 6, 2 is decrease of 4. Okay. Unsafe because 4, 4 is neither the increase or a decrease. Okay. 4 to 4, that's 0. So that's level. And then 1, 3, 6, 7, 9, because the levels are all increased by 1, 2, or 3. So in this example, 2 reports are safe. Analyze the usual data from the engineers. How many reports are safe? Begin, get your puzzle input. Okay. So we'll take our test input here. We're going to start by putting that in the test file, and we're going to go to our test, and we'll go ahead and use ints here because I think that'll be fine. We'll fix part 1 here in a second. If we look, our test input is 2, so we'll change this to 2, and we'll change this to int here. So that's good. And then this is just a grid of data. So actually I want to use, yeah, we're on day 2. So what I can do is get rid of that, get rid of this function that we created before, and then I'll do common dot as grid, and take in our input, and our separator is actually just, if we look at our test input here, our separator is a space, so we can put that here. So that's our separator. And then we're going to get this grid back. We'll call it G from this. And it's just going to be a slice of slices, or a slice of ints in this case. What we're going to do as ints as grid I. So now we get this. This will return a, here we'll look at it real quick. Grid I, which is a slice of int, which is what we want here. And then so what we can do is we can say, okay, for each row in range of G, and then we can say for each call in range of row. Okay, so this is going to be our row, so cross, and then we're just going to check each column. And then so one of the things we want to do, how do we want to do this? So we want to check, we want to index through, and we want to start I think this is, I always get this syntax confused. It's because I don't use it that often. but I think it's I is 1, I is less than length of row, I plus plus. And so what we want to do is iterate through this, right? We want to step through and we want to check the value and say, okay, is the value of I minus the next value? So we can do a math dot. Probably should have floats here now that I'm thinking about it, but it's okay. So let's do diff equal to the ABS math ABS of float 64. We'll do row sub I minus 1. And we'll do minus I. And we'll say if diff equals 0, continue. If diff greater than or equal to 3. Now let's just check that fact real quick. 1, 2, or 3. So we'll say greater than 3. Continue. So if we don't have a difference, that's a problem. If our diff between the two is greater than 3, that's a problem. Then the last condition we need is, are we increasing or decreasing? So I think what we can do is, if that should be determined by the first 2 slices, right? So index 0 and 1 should give us the slope of whether we're going up or down. So, so what we could do is, actually, we can do this here. Yeah, so we can do the absolute value here, but actually we're not going to do the absolute value here. So what we can do is say, so if it's 0, it's 0. If that, and then we can say, so we know that if it's a positive slope, so like 1 minus 3, 3 being higher, that means it's ascending, so we have a negative number in inverse. So yeah, so we could just do this and say, because we know we have I'm trying to think of like how to articulate like the slope where it's not like ugly. Because these accomplish the other two like conditions, but I know that I always want either a negative or a positive number. And so I think we can do something like this. And then I could do something like if and then we can do something like score plus plus. Something like that. So we know that our slope can be either negative or positive, and then based on the first two values, that's going to dictate whether or not it's negative or positive. We know that if there is no diff in the beginning, this is going to exit us. Otherwise, we're going to continue that slope in that particular direction. So if we run this, okay. Expected 2, actual 0. Let me see if I just have my slope values inversed real quick. So I think this should work. No, okay. Let me get rid of this logging message that I put in here earlier. Okay, so where are we at here? Let's do it. Let's print it and see what it looks like. Ah, all right. 76421 12789 97621 13245 13679 13679. Okay, perfect. So then we can actually just kind of like step through this. So 7 minus 6 is 1. So that is not greater than 3. If 1 times the slope, so if row 0 minus row 1 is less than 0, which is not, it'd be 1. Okay. So 7 minus 6 is 1 times -1. So we should continue, right? Okay. So let's do this then. Let's do hmm. I think that was my bug. Okay. So let's use some terminology from here. We'll call it safe. Safe is false. Um, and then that. All right, great. So what I did here is I created a boolean called safe, and then anytime we hit a condition that marked it as non-safe, I said safe is false. I broke out of that particular loop, and then only if safe, I incremented the score. So now that we've got that passing, if we get our puzzle input, and I take this and I plug it into 1.txt, and then we can run day 2 here, and 269 is our answer. We submit that, and we got the right answer. Awesome. Moving on to part 2. So part 2, the engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor mounted module that lets the reactor safety systems tolerate a single bad level and what would otherwise be a safe report. It's like the bad level never happened. Now, the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. More of the above examples, reports are now safe. So, Okay, so what about removing the third level 4? Oh, that's interesting. Okay, so we can't just um we can't just move our pointer forward, right? Because we move our pointer forward 6 and 4, 4 and 1. I think that would be fine here. Because when we're here, we're like, oh, that's unsafe, move forward. Okay. Okay. So if we take the same concept that we have here, let's go back to our test input. We'll copy that into test 2. We'll go back to our test here. We'll uncomment this, and then we'll uncomment this, and we'll make test 2. The answer is 4. And we'll go here and we'll make this an int. So then if we use the same logic as part 1, and then what we can do for the safe value, instead we'll call this unsafe, and we'll call this 0, and we'll increment unsafe. And we'll say if unsafe less than or equal to 1, we increment our score. And we can then just kind of say if unsafe greater than 1, we'll just break out of this entirely. That's got to be a continue, that's going to be a continue, and that's got to be a continue, right? Because we want to continue to the next one instead of breaking out entirely. But we know if we've exceeded our threshold to go and break out, that's so we can finish faster. And if our unsafe is less than or equal to 1, then our score increments. So if we run this, our expected is 4, our actual is 6. Okay, so let me get rid of some of these. Let's see here. Safe without removing any level. Unsafe regardless of which level is removed. One, two, three, 4. Okay, so this isn't going to quite work because if I say 1 to 2 is unsafe, 1 to 2 is safe, but 2 to 7 is not. Okay, and so the problem is, yeah, okay, this was my fear here, is that 7 to 8 is safe, 2 to 7 is not, but 2 to 8 is not. 1 to 7 is not. So the problem is that we can't just iterate forward. We have to say, okay, if 1 to 2 is unsafe, try 1 to 7. And then if that's not safe, try 2 to 7. Um, okay. So we can brute force this, but it's going to be extremely slow. And so we can randomly start picking out and saying, okay, these indexes are not going to work. The minute we find a single unsafe index, so let's say the 2 to 7 here, we know that we can try removing 2, seeing if that works, and we can try removing 7 and seeing if that works. Let's see if that applies here. 9762. We know that 6 to 2 is the problem, so we try removing 6. We get 7 to 2, back to 6. We try removing 2, that's 6 to 1. I think that is the better solution, is we identify the problem, the unsafe index. We try removing that unsafe index. But do we only have to remove one level to test this? Yeah, I think that's the case. We only need to remove 1. So if we know 2 to 7 is bad, I guess depending on if this is incrementing or decrementing, it would be safe to try both or all 3 combinations once we figure out what the unsafe index is. Is the input always 5? 1, 2, 3, 4, 5, 6. All right. Well, so much for the easy way out. So if we can create a function and we pass in a slice int, we return an int, which will be the index, and we're going to basically take this this don't care about that anymore. Call this row just to make this easier. We're not going to increment that because that's not the right solution. That was a poor main solution. And we'll pass in slope as well. Okay. So now we can return -1 if it's safe, and then return I. So yeah, so we'll give it row, slope, We're gonna change our solution here. For problem number 1, just because I think actually, that's not it. If our slope is -1, we increase our score. So I don't code in C++. Do, so I can't really answer that question. But I know, just in like Go as an example, reading by splitting on the input of byte array on a slide, like a here. This is what I do here. So I split the file, the byte slice, by a hard returner /n, and that gives me my input. And you should be able to do something similar in C++. Right. So back here. So if our get unsafe index is -1, then our score is increased. So we can get rid of that. So the reason I did that is because we come back here to our original like test. This should prove, yeah, so we still pass on our original condition. So now if we come back into our second test here, if we come back to here and we incorporate that here in this for condition, right? So if our unsafe index, we'll call this unsafe. If unsafe is -1, then I know I can increase by +1. There's an edge case here, I think I'm gonna miss, but I think it's okay. Okay. So now that I know what index, I can attempt to remove that index to see if my problem is solved. So um, man, how do I want to do this? We're getting close. We're getting close. Because from the index, I want to just attempt to remove it, and then the piece before and after it, and I can reconstruct um, 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 my slice. And so is that it? Okay. Well, that certainly passes that, but certainly it can't be that simple, is it? Well, let's just give it the good old college try. I have a feeling I'm missing an edge case here, and while it appears that it's going to work, I don't think it will. We'll see. 313. Yeah. Okay. So my concern is that in this example, while we do pass on the test case, I think there is a few edge cases that we're not considering where there is a difference. So let's see if we can articulate that here. Get unsafe index works fine, but I think the number is actually greater than what we're seeing here. So I think the problem is that 0 to unsafe and unsafe plus 1 gives us the condition of where we are in an 86441, we get an 8641. We identify a problem index, which is between the 6 and the 4, or actually the 4 and the 4. We're actually removing this 4, and so we get 8641 with removing this one, and that works. 13679 works. No, let's look at this one. 13245 works because we found two to be the problem index. Yeah, so we saw 2 to be the problem index here. And so we actually ended up with was 1345. And that worked. But if this was a 4, we would have saw the 2 is the problem. And we would remove the 2. We would have got 1, 4, 4, 5. And so I think if I actually add this to my test case, we know that this can be solved by removing this 4, right? So we get 1, 2, 4, 5, and that's valid. So my answer should be now 5. But I don't believe it is. Yeah. So the reason is because we're only removing that one index. And so what I actually need to do is to test one before and one after, I think. Because if we go back to this test case, right now we're removing this one, which makes this completely invalid because it's 1, 4, 4, 5. But we need to attempt to remove this one as well, which would give me 1, 2, 4, 5, which is valid. We could also attempt to remove this one, which is +1 index. That's not valid in this case, but could be valid in another case. So if I go back to my command here, I'm going to kind of just like brute force this a little bit here, but That looks weird, huh? -1 + 1. I'm just going to leave it that way for my sanity. And so if I rerun my test, still doesn't pass. Okay, why? One, 4, 5, 5? Hold on a second. Where's 1, 4, 5, 5? Okay. That explains a lot. 1, 4. I'm expecting it to be 1, 2, 4, 5. Let's see here. 0 to unsafe -1. And then unsafe -1 + 1. Doesn't feel right, does it? Oh. 1, 4, 5, 5. Actually, let me just try this instead. Yeah, this is our clue here. 1, 4, 5, 5. So why are we getting 1, 4, 5, 5? 1, 4, 5, 5. That's where they're moving the 2. We're almost there. We're almost there. There's something wrong here. 4, 5, 5. 1, 4, 5. 1, 4, 5. 5. I suppose that's part of the problem, is that I'm always expecting to start at 0 going forward some degree of value, so that the beginning number is always the right number, which would also be an issue. Yeah, that's also a problem. I'm not very smart here, guys, but we're gonna change this up a little bit, and instead we're gonna do a copy of row, and we'll call it n, destination source of type. Okay, so we'll call it n is a slice of int. So what I'm going to do instead is I'm going to copy source to destination, and we're going to get rid of that. Okay, and then we're going to do a n a delete, right? And we should be able to slices dot delete. There we go. I should be able to give it delete removes the element si of j from s returning. So n, and then unsafe, and then 1. Yes. Yes. Now we'll do n equals, and then we're going to change this to n. And then we're going to return the modified slice. About slice these items must be deleted or single. I don't think we're actually going to modify row here, so I'm gonna go with this and this, and I'm gonna forego the copy. And then that way we can change this to, it might be just easier to follow if we do this, and then we'll do a little brute forcey here, and we'll do a +1. Yeah, right. Okay. Runtime slice is out of bounds. Great. Delete removes the element si to j from s, returning the modified slice. Delete pings I is then the valid slice of s. Delete. Oh, so it should be unsafe +1. Is that true? Is that what I did wrong here? Is that the true statement here? I don't like that because it's just unsafe. And then +1. Wait a second. Read the manual, Chris. I mean, is it? I don't like the way that's worded. So we'll go with that. Actual Q. Expected 5. So why is that? One, 4, 2, 4, 5. This is really +1. Ooh, interesting. 1, 4, 5, 0. Okay, we're getting somewhere here. 1, 4, 5, 0. 1, 4, 5, 0. Mm. 1, 4, 4, 5. 1, 4, 5, 0. Oh, we're getting close. We are definitely getting close. I'm scrambling a little bit here though. So it's panicking and as everybody watches me sweat. Um so delete removes the element si colon j from s, returning the modified slice. Delete panics of j. Yeah, okay, is not valid. Slice with s. Delete is o length. So if many items must be deleted, it's better to make a single call, deleting them all together and delete one at a time. Okay, don't really care about that. Why am I getting 0? Why am I getting 0? 1, 4, 5, 0. And I get it on the first iteration. It gives us 1, 4, 4, 5. What I'm expecting is 1, 2, 4, 5. But I don't get 1, 2, 4, 5 here. Is it? Let me just make sure this isn't the issue. I have a feeling it is, but I'm not 100% sure because of the verbiage. Ah, okay. So what was happening is we were modifying the same slice and we were getting different results as we go. So that fixes my test input. So if I go back here and I run this and it doesn't crash and we get 325, I put that in, that's still not the right answer. Okay. What other test cases could we come up with here? So we know at least one scenario we fixed, which was this. What about a scenario? Let's create another scenario here where we've got 7, 1, 2, 4, 5. This should pass, right? Because 7 is actually our problem index. 1, 2, 4, 5 is completely valid progression. So this should become 6, right? Okay. One, 2, 4, 5. Slope is wrong. Aha. Okay. Good. Good. So that means that our slope being passed in is our problem. So our slope should not be determined outside. Our slope should be determined inside whatever I'm passing in, right? Yeah. We can get rid of that and that and that and that and that. It's for the better anyway, right? All right. Let's try her again. 3, 3, 3. Couldn't it be? Okay, still not the right answer. So our slope is now being determined based on the input. What other issues could we have here with our input data? Well, that should be valid, right? 1, 2, 4, 5, 3. 1, 2, 4, 5, 3. 1, 2, 4, 5, 3. Because 1, 2, 4, 5 is right, but 3 is not. So I expect this to be okay. That's fine. Okay, not a problem. What other conditions do we have here? Let's look at our input text. Let me, although it hasn't changed, you can still get the, okay. What else we got here? 2, 3, 5, 4, 4. It's kind of an interesting condition. 2, 3, 5, 4, 2, 3, 4, 4. We can add this to our test, and we shouldn't change our test numbers. Okay, that's good. What else we have here? $37, $34, $31. 29, 27, 25, 22, 19. Oof. Kind of searching for a needle in a haystack now, aren't we? 65, 68, 71, 72, 71. I also would not expect this to change anything. Aha. Okay. Why did that pass? This shouldn't pass, right? So 65 is removed. We've got 68, 71, 72, 71. 65, 68, 71, 72 is fine. No, this one's fine. Okay, that's actually right. Because you're moving 71, that one passes. So I want to say it's probably an edge case with my input somewhere that I'm missing. 37, 34, 31, 29. How about this one? This one should produce. Yeah. We'll leave this one in here. So this one should, because the slope is downward and it's removing none of them. What to do? So the next thing we can look at is kind of randomly picking from here is not really doing us much justice. Let's try this one. Yeah, so that's good. All right, let's look at this here. So this is all of my inputs and my test outputs. Thirteen, 14, 13, 14, 13. Slope is wrong. 0, 50, 50, 45, 44. Wait a second. 50, 45, 44, 43, 40, 38. Any ideas? Yeah, I'll take a clue. Orphis, give it up. What do I got? What am I missing? It's probably something. I just need to find the test case. Ah, yeah, yeah. Yeah, I don't really want to brute for it. Like, yeah, I realize that I could. It's a little less optimal, but there's just an edge case that I'm missing here, and it's unfortunate because this is typical of that amount of code where they express a good amount of test cases, a good amount of test cases, but they don't really cover the full gamut. And so there's something that I'm missing that is quite obvious here, and it's something I really didn't consider. And so I think I just need to think through these a little bit more. No, I think unsafe being reused is fine because um the re yeah, I'm reusing the variable. This is true, but only if it's -1, we're continuing here. Otherwise, I go through and I say, okay, check it with basically offset by removing that unsafe variable. If it's -1, meaning we don't find an index, then, oh, wait a second. Hmm. So, you're absolutely right. You're absolutely right. So what's happening is I'm setting unsafe based on the modified slice, which is giving me a value that is based on that. Yeah. You're right. You're right. It's absolutely correct. So um yeah yeah. So how do I want to do this then? Because I this is so terrible, but really this is the difference. So it's the original unsafe index that I want to offset forward and backwards to get our values, right? And then, but I don't want to, I don't want to, I don't care about the next unsafe iteration. You're right. What I think we can do is actually put this in a for loop of a range of 0, -1, +1, and then we can kind of clean this up a little bit. But let me actually see if this passes our test case, and then if it still passes our test case, I'm just going to rerun it and see if we get a different result other than 333. And then, yeah, that's not the case. Yeah, so I thought about that. Okay. Yeah, we can do that here. That's fine. That's fine there. But I do want it on the original one. So we can remove these, and that'll make it a little bit cleaner. But I need the original one because I need to know where we need to offset from. And so, yeah, I agree. Let's do that. Um, so it's still 333 though. So I'm missing something. Missing something else. Because we know 333 is not it. My test still passed. So I'm good there. So I didn't break anything, at least knowingly. Yeah, I realize that. I realize that. I realize that I've self-punished myself. I thought about the brute force approach earlier. And I was like, well, I could just always like remove. I mean, there's only what 5 or 6 of these at most. So, I mean, testing it wouldn't be that bad. But I think this is like a fun little approach, right? It's like more complex. But at the same time, like we can turn this into like a nice little for loop too, like a range of numbers, and then it's like a range of slice rather of index. Then it'll get even cleaner because then you just kind of go forward, back, et cetera, et cetera. Like we could do something like this, for uh, and then we could do something like we could do something like um, something like that. You take all these out. So we can break out of here. Yeah, something like that. Yeah, 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 there we go. Let's make it even more confusing. Yeah, I know, but I already know that brute forcing it is a less optimal like approach. Just I'd rather not just go through the whole process of like randomly removing each index to see if there's like another way to do it, and just know that like if we identify the first unsafe index, we can just come across the other ones and test them, and it's just fun. I did put 333 in, right? I mean, like, I'm not imagining things. Yeah, we're almost there. I just got to figure out what the edge case is that I'm missing, and then we're good to go. Um, um, you may be right. Let's see this. Origin safe to ridge unsafe. plus I plus 1 is not correct. It could be a number before. Um, yeah, but I is also like -1, right? So isn't that the number before? Isn't that what? Hold on. Isn't that what this proves here? 864. No. 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 Okay. So then you're supposing that um this is valid. So that should have increased my number. Um so this is the edge case. Yeah, so this is the edge case though, right? So like 3679 is valid because that's an increase of 3. It's an increase of 1. That's an increase of 2. But with 8 removed, so oh, I put it in the wrong file. That's why. Okay. Hold on. Still though, that's yeah, okay. Yeah, yeah, yeah. No, that's right. Okay. So we know that that is, yeah, we know that that's valid. So that's removing the first index. This is removing the last index. 1, 2, 4, 5, 3. Should give me 10 now. Yeah. So we know we're trimming the first and last index off. There's an edge case that I'm still not seeing here, and I don't know what it is. Time to look at the whole input file. Yeah, but I don't need to solve it in a simple way. Like I already know how I would approach that problem. It doesn't serve me to approach it that way, knowing I already know how to do it that way. Yeah, but it doesn't serve the approach that I want. I realize it's taking longer. I do. But this is the purpose of having a code for me, right? The purpose is to flex my ability and figure out and give myself pain so that I can become better at problem solving, right? And if I already know something is I mean, okay, so right. So what's like the longest like length of like characters here? Like 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's not so bad. But if there was like 1,000 of them, it would be like way less optimal as opposed to like finding the index. And then I would say, okay, well, if I know what the first unsafe location is, I can remove that in the surrounding areas and find a like value, right? So it is possible that my get unsafe index function is wrong. You can test that some more. Let's see here. Slope a dope. Oh, I agree. It's called premature optimization. If right. So like here's the approach, right? So I know I could already do it the other way. So typically if I wasn't familiar with it or I wasn't familiar with software engineering, I would say, okay, let me just take the brute force approach and see what my answer is going to be. But in this case, like while it may work, I'm looking to create a more optimal solution to teach myself the more optimal approach. And when I say optimal, it may not be optimal for this particular input, but I believe it's more optimal overall. And we can benchmark it later. Like if we really want to like bang this out, we can do that. But I'd rather just focus on like my test input and pander around with it for a little bit longer until I can't find a solution. Um, so I think that the answer is to look at the different patterns for all the unsafes, where we have at least one unsafe index, and then take that and say, okay, here's the different patterns, and then go from there instead of randomly cherry picking from here to see what's right and what's wrong. Because I can like look at this and say, okay, like that's reasonably possibly a problem, but I'm running out of edge case scenarios now. I suppose doing it the more brute force approach would allow me to like compare the two functions and figure out which ones are being flagged incorrectly with a more optimal solution. I mean, if we want to like go that route, we can definitely do that. Oh yeah, I mean, certainly. I've done my fair share of like benchmark optimizations. So, I mean, you're not wrong. It's like create the less optimal performant one first, prove that it works, and then test on the optimal. It's less fun for me to just brute force it. Um, so let's do it this way. We'll go this route here. So what do we want to do here? Um, so we'll do that. We'll do that. And then we will Yeah, let's look at it. Um, 76421 5583679 235 4 12453. I mean, I have. Yeah, it looks fine to me. Um, the only, I mean, I have a test case here where we're proving, and I guess I could refine my test a little bit more than being a input file, but I'm proving that if it's the last index, or if it's the first index, or if it's a middle index, we are appropriately working. So I don't know. Maybe something like that would be a problem. Oh, well, I'm in the middle of breaking things. Yeah, yeah, we can do that. So I'm I'm And then I just want to break. I do the labels and go. Yeah, okay. Do I want to just break out of this entirely? I could just break out of that, and then it goes to the next row. I don't need this. Yeah. Okay. Right. So then if we go here, and I just take this, and take this, and take this, and it can be the same input. Right. All right. Now. All right. Let's give it a shot. Right. Yes, you were right. Doing it the less complicated way, I got it right much faster. But that still doesn't help my brain wanting to do it the more optimal way. All right, so that means there was 4 records that were different between the two. So 4, 4. Yes, I know we can find out why it didn't work. This was a great idea. I'll give you that, Orphis. This is a great idea to do the less optimal one to figure out which ones are different. So what we can do, um, let's think about this here. Um, how do I want to combine these two? Part 4-ish. Let's real original names here. Yeah. Don't do what I do. All right, I have a new keyboard that I've been really working with, and I don't know if you guys are familiar with it. It's here. I'll show it to you real quick. It's the uh, not the lunar lander, but the oh man, the Voyager, and it's calling a keyboard, and it doesn't have all the same keys that you would have. It has what's called layers, and I'm getting used to them, and it makes me look like I'm terrible at typing, but I'm really not. Um, yeah. So I was thinking about that, but I think actually what I want to do is I just want to combine the two, and then um, when I don't find something in one, and then I check it in the other, then I just output the response, right? And because I mean, there's 1,000 inputs, and only 337 of them are safe. I guess yeah. Okay, fine. You win again. I'm just gonna do that. It'll be fine. So No, 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 no. Yeah, no. You bring a valid point, right? So it's like, why do it the more optimized way if we don't have to do it the more optimized way? And it's like, yes, we can brute force it. And in fact, if you go back and you look at this video at like minute 5 or 10, I was like, hey, I could just brute force this. And I was like, no, I don't want to do it that way. I want to do it the more complex way because I have this idea of getting the unsafe index. And then from there, we could just delete like one back, one forward, and we're good to go. There's an edge case. There's 4 edge cases to be precise. So I just, yeah, it's okay. I'm my own worst enemy sometimes. Um, I'm a little tired here, but I'm just trying to think about how I want to articulate this because I could just write these to a log file and we call it a day. Um, or I could just compare them in memory, which is the other option. But I think just writing them out to a file would just be sufficient. So instead of doing the pretty stuff, get rid of that, and then let's go to get unsafe. Let me just get rid of this and this, because this is overly excessive logging. It's logging like all of the different like sub cases, so it's making my logs look pretty ugly right now. And then yeah, and then we can get rid of this. Um, and then we can write with fields, and we're going to call this part 2, and we'll call part, and we'll call it 2, and we'll call it info, and we'll call it where are we at? Percent pound v, and we'll call it row. Except this is part 2, not part 1. And we will call this same. And then part 3, which actually looks nicer. We'll do that. I do not like this. Oh, it's info F and info F and info F. Yeah. Yeah. I'm being lazy now, so you'll just have to excuse me. Mm, mm, what I'm gonna do. All right. Same thing here. Boom. Okay. Are these any of these over? No. 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 Okay. Um. mm, I think these should be pretty much the same. Um. So actually, Orphis, you're wrong. I don't know how much you've done admin code previously, but um, there are problems that if you approach in a brute force way, you will not solve them computationally in a fast enough time. At least from what you could do performantly on like a Mac. Um, yeah, let's do the dash U. Um, one. Well, I mean, I have access to pretty few machines, so but I would, yeah, okay, fair enough. I'm just on a little like MacBook Air right now, so if I don't abuse what access I have. So why is this 21, 22, 25, 23, 24? Interesting. Interesting indeed. So if I put this in my test 2, I really should change this test. Oh, is that my problem? Hold on. Oh, there's actually an equal sign in here. Yeah, I don't know why that happened. So 1, 2, 3, 4. Why is this one in here? Ah, we'll fix that. Okay. There we go. So here are my 4 different ones. Well, I was trying to do the optimal way, James. Don't come in here all like it took me 2 hours too. I'm just kidding. So I went down a very, very non-brute force approach way, in which case Orphis rather, said, hey, Just do it the brute force way. And I did that in like 5 minutes. And then I'm going back and trying to figure out why I am wrong in my more, probably more optimal way. But yet particularly unsolved yet. All right, so here, let's go back to this. Let's go back to my tests 10, because I know 10 is where we want to be at for these two. What's good is I should be able to throw this test here in, and I should get one of them because the commas. It's okay. Yeah. Let's fix this real quick. So I'm gonna guess that this is the one. And this shows our difference. Yeah, okay. So what's different about this? 27, 30, 29, 28, 25. If we remove 27, we get 30, 29, 28, 25. So the 0th index is not being removed. But we have other examples of that working. Do we? Do we? But not here. Okay. So let's isolate that. Um, let's go to so -1. The value of original unsafe for the last case. Original unsafe is now unmodified. So it's going to be, oh, okay, so you mean the last test case. So this should be should be 29, and that's our problem. So the reason I think this is our issue is because if the original unsafe is 29, if we remove 30, we still get 27, 29, 28, 25, which is not valid. Yeah. So I think maybe the answer is that our unsafe should be the start index. But I wonder if we end up with the inverse problem. Because actually, technically, I'm not returning the unsafe index or the starting position of the unsafe index. I'm actually returning the next iteration of one, right? So the benefit here is I don't end up with like a index out of bounds issue, but um, what's interesting is I am using the same routine, but only for validation up here, where in fact here I'm actually expecting it to return a valid index. But what if I instead, I would like to test this a little bit more. Um, and then what if we just simply, let me get rid of my logs. Yes, that was my concern here, is that now my optimal solution in some scenarios um, will not do well. Well, we can find the exact location here. Not there or there, but here, yeah. With a -1. I'm sorry, what do you mean by you could probably remove -2, -1, 0? There you go. Yeah. That's what I did here. So now that we have it working in the theoretically more optimal way, um, the question is how do we prove it? So we could benchmark test and go. Um, that might work. We could probably bench them, compare the benches. Um, but we figured out our issue. So the solution was just I need to actually return the actual unsafe pointer instead of the one after it, and that solved all of our problems. Um, so our issue was in fact get unsafe index was returning the wrong index. So now let's just test it because I mean we're already here. It's late. Might as well. Let's see here. If I do Golang time function, let's see, is there an efficient way to calculate? No. I mean, should we not just like do the benchmark? Should we not do it? I mean, I've got benchmark test here already set up for the previous. We'll use test 2. And we'll call this benchmark part 3, part 2. Sorry, I got rid of my live stream chat. Well, yeah, but I mean, we're here. I mean, why wouldn't we do it if we're already here? Well, it's more optimal in a lot of different ways. Why that matters? I don't know, but it makes me feel good. All right, well, that is spending way too much time in Advent Code Day 2. Easy problem. I made it way more complex than was necessary. Thank you for your help. Appreciate the dialogue and the back and forth there, Orpheus. It was fun. Orphis. I don't know why I say Orpheus. I think Morpheus, and then I see Orphis, and I say Orpheus. I apologize. It's Orphis. But that was fun. Plan on doing the rest of Advent Code until I run out of things to do. I know from last year some of these things get kind of cool with mazes, etc. I've solved those last year. Plan to do that again this year. And when things become a little bit more entertaining and we can visualize some things, I've got a couple of different things I'm experimenting with Fine and some other things. If you guys haven't seen it, I've got some stuff that I've experimented with when it comes to chess and AI. And so just like do a whole bunch of listings here. But here I'll just kind of, I actually forgot where it was. I think it's probably auto chess. That's the terminal version. I have a couple of different versions. One that's in the terminal, but then I also have one where we're actually, it's more of a bind board. And let me see if I can find that one. It's pretty cool though. The idea was have different LLMs play chess against each other. And so I kind of successfully did that, built that using some different AI tools. But kind of some neat little projects, but kind of gives us an interesting way of like visualizing different things. And so maybe it's this one. I don't know where it is anymore. I'm all over the place at the moment. But I have some interesting ideas as far as getting those things visualized. Us actually working through grid, working through different things, and I think it'd be pretty cool to visualize some of these Avid code projects. And so we'll dive into that a little bit more as we progress, and I'll make my life overly complicated as usual. So stay tuned. We'll have fun. See you guys tomorrow night if you're interested. This has been good fun for me. Hopefully it was good fun for you, and see you next time. Yeah, we'll get